Welcome to the session on correlation. The objectives for this session are to draw and interpret scatter diagrams for a bivariate data. What is bivariate data? Data which has pairs of values for two variables is bivariate data. It can be represented on a scatter diagram. So, for example, the following diagram shows the data gathered from a cafe. It displays temperature against sales of soup. The independent or explanatory variable is usually on the x-axis. So notice we would expect temperature or weather to have an effect on the number of bowls of soup sold. So therefore we have temperature on the x-axis and the dependent or response variable on the y-axis. So, because the number of bowls of soup sold reacts to changes in the independent variable, which is in our example of course temperature, we have that on the y-axis. Correlation describes the nature of the linear relationship between two variables. So, if we have a scatter plot like this one, this represents a strong negative correlation, which means as one variable increases, the other one decreases linearly or in an approximately linear manner. Here, the scatter plot displays weak negative correlation. So notice that the points aren't as tightly clustered around a straight line. Here, we seem to have no linear correlation whatsoever. And here, we have weak positive correlation, so the points seem to be increasing in a linear direction, but they're not tightly clustered around a straight line. And finally here, we have strong positive correlation. The points, as you can see, are tending to fit a more linear pattern. So here we have highlighted negative correlation. As one variable increases, the other decreases. And here we have positive correlation. As one variable increases, the other increases also. Let's now have a go at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's have a go at example 2a first. The distance a sample of 8 students in a college live away from college and the time it takes them to arrive at college is provided in the table shown on your screen. Draw a scatter diagram to represent this data. So here it is. Notice that distance is on the x-axis and time is on the y-axis because the time taken is affected by how far away or how close a student lives to the college. In part B, we're required to describe the correlation between distance and time. Notice that the points on the scatter diagram seem to be following a pattern close to a straight line. As one variable is increasing, the other variable is increasing also. So we would say that the correlation between distance and time is strong and positive. Now interpret your answer to part B. Of course, as we said earlier, as the distance from the college increases, the time taken to reach college also increases. This is what we mean by correlation being strong and positive. We're now going to take a look at causal relationships. We can say two variables have a causal relationship when a change in one variable causes a change in the other variable to occur. Sometimes variables are correlated, but it cannot be concluded that they have a causal relationship. We must consider context when deciding whether relationships are causal. So let's take a look at an example. A student has some data indicating that foot size and height have a strong positive correlation. Can the student conclude that bigger feet cause people to become taller? Of course, we can't conclude that at all. The two variables are positively correlated generally, but we can't conclude that one variable causes the other to change. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's have a look at example 3a first. A sales manager records some data on soup sales and ice cream on various days in the year. Describe the type of correlation shown. So let's solve this. We have in the diagram the number of bowls of soup sold on the x-axis and the number of ice creams sold on the y-axis. As one variable is increasing, the other is decreasing. So the relationship is a strong linear correlation because the points are also following a straight line quite closely. Now let's take a look at part B. The sales manager claims that an increase in the bowls of soup being sold causes fewer ice creams to be sold. Give one reason why his conclusion is incorrect. So let's solve this. We need to think about what other variable might be causing the changes in these two variables to occur. Of course, both variables are actually affected by a third variable, namely temperature, and not by each other. This brings us to the end of this session. If you have understood its contents, you should be able to draw and interpret scatter diagrams for bivariate data. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.